All right, we're starting with number 14, and this time we're looking for points of inflection and concavity. So concavity, remember that means a second derivative. So we're going to look at the domain first. The domain is from negative infinity to positive infinity. Our function is y equals negative x to the third plus 33x squared plus 6x minus 42. So our first derivative is negative 3x squared plus 66x plus 6. That tells me increasing, decreasing maxes and mins. My second derivative is negative 6x plus 66, and that's going to equal 0. So I'm going to subtract 66 from both sides, and then divide both sides by negative 6. So far it's the same thing as what we did with increasing and decreasing and maxes and mins. So I have x equals 11. I'm going to make a number line with a point at 11. So I need a number to the left of 11 that I'm going to put inside of my second derivative this time. And then, so what's the number to the left of 11? Let's try 10. So negative 60 plus 66 is positive. And then after 11 would be 12. So negative 6 times 12 is negative 72 plus 66 is negative. And I just used the wrong arrows. I just use arrows for increasing, decreasing, maxes, and mins. Sorry. All right. So we have increasing and then we have decreasing. Okay. So where's my point of inflection? My point of inflection is at 11, and then we've got to figure out what the y coordinate is. So I have negative 11 cubed plus 33 plus 33 times 11 squared plus 6 times 11 minus 42 gives me 2686. So that's my point of inflection. That's where it's going to change concavity. So where is it concave up? It's concave up from negative infinity to 11, and then it's concave down from 11 to positive infinity. Okay? So number 15, we have the same problem type. Negative 4x to the third minus 6x squared minus 54x minus 12. And that's what y equals. So my domain is from negative infinity to positive infinity, just like on the last one. My first derivative is going to be negative 12x squared minus 12x minus 54. My second derivative, which tells me about concavity, is a negative 24x minus 12. So set that equal to 0. Add 12 to both sides. Divide both sides by negative 24. And we get x is negative 1/2. Okay. So this is my second derivative. That's where we're going to put the test points in. And then we have our number line with our potential inflection point at negative 1/2. I am going to grab negative 1. So negative 24 times negative 1 is 24, minus 12 is positive. And then grab 0. 0 minus 12 is negative. So I have an inflection point at x equals negative 1/2. And then it's concave up from negative infinity to negative 1/2. And concave down from negative 1/2 to positive infinity. And then we have number 16, which we're going to slow down a little bit. So number 16 is a little bit more challenging. We have f of x is x times the square root of x squared plus 3. And my domain is all real numbers because there's nothing that I can square to make this go negative. Whatever I square is going to be positive. So look at it this way. If I have x squared plus 3 and I need to make that greater than or equal to 0, subtract 3 from both sides. X squared is greater than or equal to a negative number. And that's not going to happen because x squared is always positive. Okay? So, I don't know what I just said. What I meant was everything that you square is going to be greater than or equal to 3. So your domain is still all real numbers. Okay? You don't have to worry about generating negatives. So I'm going to rewrite first. And raise that to the 1/2 power. And now I'm going to use product rule and I'm going to start writing over here. So product rule for the first derivative says I've got the first times the derivative of the second. Don't forget about your times 2x on the inside. Plus the second times the derivative of the first, which is 1. Okay, I'm going to pause a second. My 1/2 and my 2 reduce, and this leaves me with an x squared. So my cleaned up first derivative is x squared over x squared plus 3 to the positive 1/2 power plus x squared plus 3 to the 1/2 power. Okay? So for this one, I need to use quotient rule. For this one, it's just power rule and chain rule. So I have my second derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And then we're going to add plus 1/2 x squared plus 3 to the negative 1/2 times 2x. So that says 1/2 x squared plus 3 to the negative 1/2 times 2x. So what can I clean up here? I can clean up, what can I clean up? I can clean up a 1/2 and a 2. I can clean up, this is all equal to 0. I can clean up this 1/2 and this 2. So right now this gives me 2x minus x to the third times x squared plus 3 to the negative 1/2 power. Oh, I just forgot an entire chunk. Good heavens. Alright. So 2x times x squared plus 3 to the 1/2 power minus x to the third x squared plus 3 to the negative 1/2 power all over x squared plus 3. Plus, and remember when you squared this, it came out as just raised to the first power. This is going to be x squared plus 3 to the negative 1/2 power, and that equals 0. Okay, so this is where it gets a little bit more dicey. We're going to set this thing equal to 0, which means I'm going to add this chunk over to the other side. Okay, so now I've got 2x squared plus 3 to the 1/2 power minus x to the third, x squared plus 3 to the negative 1/2 power over x squared plus 3 equals, I'm going to add this chunk over to the other side. And that's over 1, and now I'm going to cross multiply. So x squared plus 3 to the first is my base. X squared plus 3 to the first, or to the negative 1/2 is my base. So that ends up being x squared plus 3 to the 1/2 power. Because I add my exponents together, so an exponent of 1 and an exponent of negative 1/2 becomes an exponent of 1/2. Equals 2x squared plus 3, 2x squared plus 3 to the 1/2 power minus x to the third, x squared plus 3 to the negative 1/2 power. Sorry, I paused it so I could double check that I wasn't leading you astray. Alright, not that you know I paused it, but I just did. Anyway, alright, here we go. So I'm going to subtract these like terms together. So that gives me 0 equals 1x squared plus 3 to the 1/2 power minus x to the third, x squared plus 3 to the negative 1/2 power. And I need to flip my paper. So I've got okay, so this is what I have so far. Let me make sure I wrote it down right. Yes, I did. Okay, so I'm going to add this chunk over to the other side, and I'm going to write this in the denominator. So what I have now is an x to the third over the square root of x squared plus 3 equals x times the square root of x squared plus 3. So I'm going to cross multiply these. So that gives me x squared plus 3 equals x to the third. So when I multiply this, I get x to the third plus 3x equals x to the third. So I just cross multiply both ways. I'm going to subtract x to the third from both sides. I get a negative 3x equals 0. Divide both sides by negative 3 and I get x is 0. So I've got a point of inflection at x equals 0. Alright, so you'll need 2 test points. So I would choose negative 1 and positive 1. And I would put those, I'm going to let you do this part. I'm going to put those into the second derivative. So just very, very carefully so that you can determine sign changes. So remember to use your proper arrows. It'll either be a concave up or a concave down or a concave up, concave down. and then you can determine the concavity from there. So this isn't the answer. This is the arrows that you're going to choose from on either side of 0. And that's going to be it for the first video.